Okay. Okay, so now we want to change the code to have the next outputs, the second outputs. We want to have level by level traverse. So right now we have only, you know, the output for this, the tree will be 1, 2, 3, 4, 5, 6, and 7. But right now we want to have a list of lists, or, you know, a 2-dimensional array. So actually we want to have this guy. Okay, we want to generate this in the BFS algorithm. Okay, so do you remember, you know, the queue we had, you know, let's say we had 1 here, and we pop this and put, you know, 2 and 3, right? Whenever we start the while loop, in each round of this while loop here, in the previous solution, we popped 1 by 1, right? But if we know the size of we extract the size of the key at each step. Actually, size of the queue at each step is the size of that level. In the beginning, we have only 1. Let's say if we calculate the level, you know, size of the queue at first, you know, before popping, okay? And then we will pop all of the elements of that level. And we will pop only 1. In the second step, the size of the queue is 2. And we will extract it, and we will calculate this. And then we will, instead of, you know, popping only 1 of these guys, we will pop both of them. We will pop both of them. So the first one we added in the list like this. In the second time, the second round in the while loop, we will check the size of the queue, which is 2. Right, and we will pop both of them. Pop, you know, in one for loop, we will with for loop with size of 2, we will pop 2 elements, and we will add in another list the output. And whenever we pop, definitely we will push, you know, the children 4, 5, 6, and 7. In the second round, we will go in, you know, the size of the queue, because we popped, you know, the previous elements, right? And the size of the queue is 4. So we will have a for loop with the size of 4, and we will pop all of them, and we will add in a temporary list, like, you know, the for 4, 5, 6, and 7. And at the end, you know, the queue will be empty. And we are, you know, populating the whole result. You know, whenever we have a temporary, you know, list or array, we will add in the final result. With this, you know, the only difference is you need to calculate the length of your queue before popping your elements. We don't want to pop 1 by 1. We need to find at each round the length of the queue and pop all of them and add all of them in the results, and then go forward. That's it. That's the only difference. I want to right now, you know, try to change only this code, and you will see how it will be. It is really easy to change this code with some simple changes. It will be converted to the next element, next problem. So I want to go using, you know, the blue color. So as I said before popping, we need to extract the level size. So that's why I want to add here level size is equal to len of q. Okay, so we have len of q here, and now instead of, you know, popping, we want to have a for loop for popping. So let me shift all of these guys, because, you know, I want to only shift all of these guys because of, you know, the indentions. Okay, so let me update. Level size is len of the key, right? So right now we want to do a for loop, but at each round we want to create one of these, you know, lists, right? You know, one of the temporary lists. So that's why I need to define a current level. We want to save all of these current levels in one list, and then at the end, we will add in the result. Okay, so I need to define a current level as an array. So because I don't have a space here, again, let me use this guy. Move this a little up. Okay, so let's go and here I wanna only again define a current level, which is empty list at first, and then I want to go and write my for loop. So for the for loop, we will go for, let's say x, doesn't matter, here is in range level size. So we have a for loop. X is not important, it can be any variable, or you can use underscore in the in Python. It doesn't matter. Only we want to repeat for level size. And so inside of this for loop, we will pop, instead of adding in the results, I have to change this guy results to current level. Because we are adding all of the elements right now, in this for loop, we are populating all of the elements of current level. We will appending all of them in the current level, and again, we will do, the same in the same manner. We will add, all the kids. And after we finish all of the, the current level, right now we have our current level. For example, let's say we have 2 and 3 right now inside of the current level. Now it's time to append this inside of the results after we finish the for loop. Let me erase these guys. After for loop is finished, we will write, the result dot append. So in the result, we append the current level, which is an array. So we will have array of arrays or list of lists, or vector of vectors in the C++. So you will have append a current level. So we append this at the end after we finish the same, exactly same as the first solution. We will return the result. Okay, as you can see, this is exactly same, but because we wanna generate level by level output, we have to be aware of the level size. That's why only we don't want to pop one by one. We want to pop at each level. We want to pop all of the levels. So that's why first we detect in this, in the blue line, blue parts. First of all, we detect, we calculate the length of the queue, and we knew that the length of queue is the level size. And we populate in the for loop with the size of the, our current level, and create our current level array. And then we append in the result.